Alright class, today in this video we're going to find the intersection of two lines 3D. And when you're talking about 3D, there's several different situations. You can have the same line, you can have intersecting lines, you can have parallel lines, but you can also have skew lines. So that's one extra possibility that you don't have in 2D. Alright, so here's our two lines. R1 of t is 2, 1, negative 1, plus t times 3, negative 1, 4. And R2 of s is 1 minus 2, 4, plus s times 5, 1, negative 3. Okay, so if they're parallel, so I didn't ask this, but if they're parallel, these two vectors should be scalar multiples of each other. Okay? So you could inspect that just by looking at them and tell whether they're parallel or not before you do anything else. You could also, if they're, if these two vectors are perpendicular, the lines are perpendicular. Now that doesn't mean anything with this question, because perpendicular lines in 3D can either intersect or still be skew. So we still have to sort of do the work here. All right. So if they intersect at the same x, y, and z value. So the easiest way to sort of do this is we get our x's and we read our equations off. So that's in the top equation, that's 2 plus 3t. And 1 plus 5t, 5s, sorry. Okay, and then we have our y equations, and that's 1 minus t equals negative 2 plus s. And then we have our z equation, and the z equation is minus 1 plus 4t equals 4 minus 3s. Now we're going to use all three of these, but we need to use two at a time. So we know if we have an equation of two unknowns, two equations of two unknowns, we should be able to get a solution unless there isn't one, and we can talk about that too. Alright, so what we're going to do is we're going to couple these two equations here. Alright, and what can I do there? So I can take the x equation and I can take the y equation. I'm going to multiply the y equation by 3. And let's see, we get negative 6 plus 3s over here. Okay, so when I do this, the t's cancel. I'm going to get 5 equals negative 5 plus 8s, and that's going to mean that so 10 over 8, which is 5 over 4, so s is 5/4. Now, does this mean they intersect? No. They could still not intersect. What it means is if they intersect when s equals 5 over 4. And then we can take that and we can solve for t. So I'm going to substitute it in the y equation, and let's see, I'm going to get that minus t equals minus 3 plus 5/4. So I need to combine those. That's 12/4, negative 12/4, and negative 12 plus 5 would be 7, and it's going to end up being negative there but positive when I multiply by the negative sign. So if my two lines intersect, and I'm not showing you all the work, am I? If my two lines intersect, they intersect when s equals 5/4 and t equals 7/4. Okay? That still doesn't mean they intersect. So how do we figure out if they intersect or not? Well, that's what the third set of equations is for. So we have minus 1, and I'm going to plug in the value for t, which is 7/4. Is that equal to, and I'm writing a question mark there because I don't know, 4 minus 3 times 5/4. Okay, so let's see if we can figure this out. That's going to be 28 over 4. That's going to be negative 4 over 4. So that's going to be, actually that's really easy, isn't it? That's just going to be 6. Okay, and then that's going to be 15 over 4. That would be 16 over 4. So 16 minus 15 is going to be 1 over 4. And clearly, still keep the question mark, clearly that's a false statement. So what does that mean? That means my lines are skew. Okay, so let me talk about one other thing. So if they had intersected, so let's just make up some nice values. If they intersect when t equals 1 and s equals 2. So the point 1, 2, that's not actually a point in 3 space. So that's not the intersection point. So if this is the case, if they intersected when t equals 1 and s equals 2, so if you got to this point and you got a true statement, you know they intersect. So you would then find r of 1, or you could find, or sorry, r1 of 1, or then you could find r2 of 2. And I always suggest that you do both of those. They should be the same point. If they're not the same point, then something's wrong because they were supposed to intersect. Okay? So that's how you find if lines are intersect or if they're skew. Once again, parallel and perpendicular are a completely different story. Much easier. Just look at the direction vectors. Okay?